So our next speaker is Jacob Richter, and he's going to be telling us about the mlrHyperopt package, which is for effortless and collaborative hyperparameter optimization experiments. Take it away, Jacob.
Thanks for your introduction, and thanks for being here. The title is quite lengthy, but let me get into it. So first, I want to start to motivate the usage of my package for Carrot users. Afterwards, for mlr users, then I will explain that it's not only a package, but actually a website, and we also have an API to interact with this website. And then I want to explain how to use this package for really simple parameter tuning for machine learning methods. And in the end, I will show you some conclusions. So the motivation for Carrot users is that I am not a really avid Carrot user, but the first thing which struck me when I use Carrot is that when you do a really simple random forest training, it takes quite some time. So then if you read the manuals, you see, okay, it does automatically hyperparameter tuning in the background. So this kind of explains why it's here a bit slower, but I don't know why it's actually so much slower, like more than 10 times actually. But we can see that, okay, here it tried 3 different values for the mtry parameter of the random forest, and actually sets this to the best setting at the end. So it's kind of useful in a way for like beginner users who are not really sure which parameters to choose. You can actually find out what parameters will be tuned in advance by using this line here. But here you notice that you don't know which exactly how this parameter looks like and what values will be tried. So to really see what will be going on, there's no other way than to look into the source code. I don't know if you can read it, but it's also not so important. So you see in here that there's some way that the search grid will be built according to the number of variables in the data set, and if it's a vector or a regression probably. And what I noticed also when I looked to the other files is that there were some strange things going on. So the grid search for the parameters, for example, for the boosting method, is that you have the entries here, and actually the parameter space you tune over increases the more budget you give to your tuning, which does not make so much sense to me because I don't want to spend so much budget, I still might want to try out the big values because they're probably better. But then, if you look at the random search, also from Carrot, you'll see that the values are actually here drawn from a range that actually makes more sense, in my opinion. But of course, these things are always to be discussed, and that's also one essential aspect of my package. So if you look at mlr, and let's say I want to do parameter tuning for the random forest, I can look into the parameter set by calling getParamSet. And here I just subsetted it to just the tunable parameters because otherwise it would have been really lengthy. And we see the nice thing in mlr is that actually all the parameters that are present are also represented in the structure here. And you see what is the default value, and you also see the possible value it can take. So for example, entry can be 1 and a really high number. But for tuning, this is really unfeasible because there's unfortunately no good tuning methods which can handle infinite bounds for the parameter space. So you might want to set a maximum number. Also, you see that this set is really big, and even though all these parameters may somehow have an effect to the performance, there might not actually be really worth to tune over, especially as the more parameters you tune, the more complicated the tuning author gets or more budget it might take. So you might just want to tune a subset of these parameters. So in mlr, there's no other way than to think and have some knowledge about the method and come to your own subset, parameter set, which is a subset. So there is this, it's a package parameter helpers. I will have a link later in the slides, which is like an integral part of mlr, but can also be used independently. But here, so you can just define a parameter set, and I think it's quite understandable what these lines will do. So we have an integer parameter, mtry, which I want to try values between 1 and 4, and the same for the node size between 1 and 10. And then I can just call tune params, which will do exactly the tuning. So I know what will be going on there. So then let me come back to caret. We see here that I decided that I also want to tune over the node size. If I don't want to do this in caret, I have to build my own grid, my own search grid. But then caret complains that the tuning parameter grid should only have the mtry column. And yeah, to actually tune over node size, I would have to write my own random forest method. And I think that's a bit overly complicated in this way. So yeah, I prefer mlr there. And to conclude, just really shortly, is in caret, the tuning is a default, which is kind of nice for not so advanced users, or also just if you want to have it simple and quick. And it's really easy. But to deviate from the defaults is kind of a hassle, and you also then need expert knowledge to implement this stuff and then to make up your mind what parameters you might want to tune. And mlr, on the other hand, to train works like we would expect it from the default package. This is why is an advantage in my point of view. But the tuning needs expert knowledge, because then you have to decide which parameters to tune over. And deviating from the defaults is also really easy in mlr. So yeah, to solve this problem in mlr, we might want to save this expert knowledge somewhere. And there my package mlrHyperopt comes into play. So it enables you to access a web database of parameter configurations for many machine learning methods. And why did I choose to make such a complicated online database for it? Because the defaults in the packages will be always controversial. So some people say, okay, you have to tune this, or this is an important parameter space, or another. And I don't want to solve this discussion. I just want to give the option to have the possibility to have multiple sets you can use. And also the knowledge changes over time. So there are still papers about the random forest, if you have to tune the entry value or not. Still ongoing discussion, so you can just upload what is, in your opinion, the best parameter set and then have it free for discussion. And also the defaults might differ for different scenarios. So you might not always want to tune this value because it's really expensive, or there can be numerous reasons. So the way mlrHyperopt stores the tuning parameters is in parconfig objects. They consist of a parameter set of the tunable parameters, or fixed parameter values where you can override the defaults of the learner, and also, of course, the associated learner, and you can put a node. So the parameter set is actually mainly work of the package paramhelpers, which is joint work with Bernd Bischel and many other great guys. And there, as we saw before, the parameters can be real valued, can be integer, discrete, logical, but more, the parameters can also have transformations to account for a non-uniform distribution of interesting regions, or you can have requirements to build like a hierarchical structures. And we also have a quite new feature that the bounds and the defaults can depend on the task size or features of the task, which of course for the random forest will be also quite handy, because the mtry value depends on the number of columns. So when you want to start with a package, I recommend you to go to the website, and there you can click on this link, and then you see all the uploaded parameter configurations. And I think it's quite nice to see how they are defined here. You can really see it in a really easy way without having to be an expert or something. And then you see which parameters are from interest and which regions are tuned or should be tuned. So how to access this API? For example, now I have like a new method I don't know anything about. It's called Ranger. I heard that this is a quite good random forest implementation, but I don't know what parameters I should tune. I can just say, download parameter configs for this learner class. Then I will get this result. Okay, I here just have one proposal. And then I can access this parameter configuration. And here you see that the default and also the constraints depend on P. And P is, in our notation, always the number of variables in the data set. And so first, because this is unfortunately not yet integrated into MLR, we have to evaluate this parameter expression set, these parameter expressions, on the task, which is given here. But don't worry, everything is actually also explained on the website of the package. There's 2 vignettes which should help a bit. And then you can just set the hyperparameters of the learner to the given default parameter values, and for the tuning you can just choose the parameter set which was extracted from the parameter configurations of the database. And to upload the thing is also quite easy. You just define your parameter set. Here you can see actually I choose a bit more complicated example for tuning an SVM. You define your parameter set to have these values C, which is from 2 to the power of minus 5 to 2 to the power of 5, and you actually can do these dependent parameter sets I just told you about. This, I would recommend you to read the documentation, or yeah, I will put the slides online, then you can just read it. You don't have to understand everything now. And yeah, in the end, of course, you just have to call upload parameter config, and then it will be stored in the database. So in the moment, everything is done anonymously without registration. I hope the database won't get spammed, but well, I will be happy also a bit. So feel free to play around with it. When it's really in heavy use, I have to think about doing like a token or something. And yeah, the bonus here is that you can also use this for Caret or for any other stuff, because these parameter sets are not bound to MLR so much. There are some nice helper functions like generate grid design, generate random design, generate design, which generates a Latin hypercube sample. And you can generate a design of defaults, which just will put the defaults in a data frame. And then I can also put this data frame actually to Caret and use it there. And yeah, you can just say download parameter configs for the learner and the net. And then I will just generate a random design, and I can put it into Caret, and it will also work. So I mentioned that Caret is really easy in the way that you can do hyperparameter tuning with just one line, because it actually forces you to do it more or less. I also wanted to do this in HyperOpt, in the package, which goes with the call of the function HyperOpt. And it really has quite simple heuristic. So if you have one parameter or 2 mixed parameters, then it will do a grid search. It will do a random search if you have over 2 mixed parameters. And it will do a Bayesian optimization with MLR MBO if all the parameter sets are numeric. Because there we think that Bayesian optimization works quite well. But you don't have to worry about it, because HyperOpt just decides more or less automatically. And so you can just say, okay, I want to take this task, and I want to use this learner, and you call HyperOpt, and in the end it will give you, here not the accuracy, but the misclassification error, and the parameter it chooses automatically, which is quite simple to use. But of course, now you ask, okay, will it be better than Caret or worse? So I did a small benchmark. I used some random data sets from OpenML, which have been used in other studies as well. And I did a tuning with a budget of 10 and 50 evaluations on a 10-fold cross-validation. And here are all the results, but they are obviously too many to be really understood. So I had to find a way to sum them up. And I did a really not so statistically clean testing because I didn't adjust for the multiple testing, but just to get a small glimpse at the results. So when you have a budget of 10, mlrHyperopt is in 40% of the cases better than the grid search, and 12% better than the random search, and nearly 50% better than the default. But what bothered me here is a bit that random search of grid is actually the best in beating the default. But if you increase the budget, the random search is surprisingly still very good. But I think it's kind of the same here. But that is also already a message that you should actually probably use the random search in Carrot and not the grid search. But unfortunately, the grid search is the default. So yeah, maybe think about that if you use Carrot, if you want to use it. And if you really want to look at the results, because I was a bit interested, so is there this one learner which is always the best? Actually, there isn't, although sometimes people say that the random forest is always really good. But you see that the SVM actually, on some data sets, also performed best after tuning. I guess you should take a closer look at this in peace later. So the lessons learned is that parameter tuning is only beneficial on some data and for some methods, because we saw that at least in some cases we were not significantly better than the defaults. But obviously you don't know in before, right? And yeah, the Carrot grid search has performance problems on big data sets. I didn't include these results here, but that was a bit strange to me. I think there's something strange going on with copying the data or something. The random search in Carrot is actually faster in some cases. But I could also observe that Carrot does this submodel trick, for example, for GLMNet, that they just learn it on the big setting for entry, for example, and then you can access the performance of subsets of these models. Yeah, and the benchmark indicates that the random search is actually better than the grid search. And so the main message I want to bring at the end is that with mlrHyperopt, we can, in combination with OpenML, do a way of transparent and reproducible benchmarks, because then I can just say, okay, I tuned this machine learning method on a parameter space with the ID of something on the database of mlrHyperopt, and I used OpenML task, another ID, and then you already have some kind of really simple way to define what your benchmark is. And of course, what I want to implement further is that you have a voting system for different parameter spaces and advanced statistics of how many things are accessed and stuff like this, like you see it on OpenML. Yeah, and you can download the package already. You can install it. It's not on CRAN, but I guess you guys know how to install a package from GitHub. So thanks for your attention. Yeah.
Thanks very much, Jacob. So unfortunately, we don't have time for questions, but you can talk to Jacob after the session.